Good morning, all of you. So, welcome to the live class. Here, in yesterday's class, I discussed about activity 1, especially how to find out acids, bases, and salts using the indicators. So, that we discussed in yesterday's class. So, here we are using mainly litmus papers and phenolphthalein methyl orange. So with that, how you can identify the nature of the substance, either acid or base. And also you are able to identify salts. If there is no effect on the litmus paper or maybe on the methyl orange or phenolphthalein. So that observation is also given in this table. So now we will go for another topic that is specially about laboratory olfactory indicators. Olfactory indicators. So it is given as activity 2 in your textbook. So here what is actually this activity 2 is? Here it is mainly about olfactory indicators. Here, what are olfactory indicators here? Simply, an indicator which can help you to find the nature of the substance, by the change in the smell of an indicator. So, indicator that which can change its smell using order, changing its order. So, that can be called as here. Olfactory indicators. So here simply you are able to use that olfactory indicators here, that order smell changing substances. So eyes olfactory indicators we are using here. Vanilla essence, clove oil, onions. Right. So here simply for conducting this activity, you are required a few materials, right? Few materials, what they are here called as required materials. So our aim is to observe olfactory indicators. So here, what are olfactory indicators? That substances which or whose its smell changes in different mediums. So for that, your required materials are here onions. Then here you are required a knife for cutting the onions. Chopped onions we are going to use here. Plastic bag, polythene bag, carry bag. You can use a carry bag. Here you are required one fine cloth, cleaned cloth, fresh cloth. Also, you have to collect 2 more indicators, that is vanilla essence. The next here you are required clove oil. These are minimum required materials for us. These are minimum required materials for conducting the activity. Then what is the procedure here? How to conduct the activity? So for that, just you need to take a finely chopped onions. So you have already onions and one knife. So take knife and finely cut the onions. Then use that finely chopped onions and a fresh cloth what you have taken. Finely chopped onions and a fresh cloth, clean cloth. Then take a polythene bag. Just keep that finely chopped onions and fresh clean cloth together into the polythene bag. Then tightly you can use also a thread to close it tightly, a tight packing. Then keep this polythene bag along with the finely chopped onions and clean cloth together into the refrigerator overnight. So keep this in the refrigerator and close the door. Keep it for 24 hours, right? Overnight. Then next, take it out in the next day morning. Then open it. What you placed, onions and clean cloth. Take out the clean cloth from the bag. So we are taking out. Then you have to observe the smell of that clean cloth. So what the smell you can observe here? You can observe the smell of the cloth as onion smell. So we can smell it, onions smell. Just observe the smell and get something idea about the smell of the cloth. What you smelled. So we have smelled onion smell from the cloth. Order of the cloth is like a onion smell. Then here, behavior of this onion in the presence of acid and in the presence of a base, we have to experience. What does it smells? Is changes it smells or remains as same? Just you have to take an acid and a base also. So take a piece of cloth from it. Piece of cloth from it. So take a small piece of cloth from this, then add 1 or 2 drops of acid on it. 1 or 2 drops of onion on the cloth surface. Then next here, just you have to smell it again. Smell it again. Then identify the difference. First you observe the smell, then also you are going to observe the smell. So here 1 more cloth piece is taken. Again adding 1 more substance on the cloth. What is now base, NaOH. Previously we added HCl on the first cloth strip. On the second cloth strip, I am adding NaOH solution. So 1 or 2 drops of NaOH solution added on the second cloth strips. So here, before smelling, we have to do 1 more thing here. That is what? Just use a fresh water to rinse these cloths. So rinse the cloth strip one after the other individually. So first take first cloth strip, rinse it in the water. Take the second, rinse it in the water. Then individually you can smell the cloth. Suppose this is a HCl added on it. HCl is added. Then observe the smell of this cloth. Next, observing the smell of another cloth strip, that which is added by NaOH. Next one, NaOH. So here you are smelling, observing the odor of the cloth, smell of the cloth, because here one of the cloth strip is added by HCl and the other is added by NaOH here. That smell you are observing. Then what does it smell? Observe. Just note down it. Is there any difference, or it is smelling same as the previous one? Well, fresh cloth kept in the refrigerator along with the onions. So it is adopted onion smell. It is adopted onion smell. So that you have to keep it in your mind. Then what we are going to do here, simply we are taking a test tube. Or taking a test tube. Then take few drops of HCl into the test tube. HCl into the test tube. So HCl is taken. The next what to do? Adding clove oil. 1 or 2 drops of clove oil. Before adding, just smell the clove oil. Something idea you will get how it is smelling. Then observe that order of clove oil in the presence of acidic medium. So adding clove oil into HCl solution. Clove oil and HCl solution, both we are taking. Observing the smell again, same thing, observing the smell. Then here, just get an idea, note down it. Is there any change before and after adding HCl and clove oil together? Next thing, take one more test tube. Now you are adding into this vanilla essence. Previously clove oil is added, right? Clove oil is added. Now we are adding vanilla essence and clove oil, both together. Then again observing the order of that. So fill that with vanilla essence, then observe the order. Clove oil. Here what happened? Change in the smell we are going to observe. So here simply in a test tube we are taken in first attempt HCl taken, next added clove oil. In the second attempt HCl and take a base NaOH and same thing, clove oil. HCl, clove oil, NaOH, clove oil. Both you can smell it. Remember it. Then in the second attempt, same thing we are following. We are taking the test tube, adding HCl and adding vanilla essence, right? Clove oil and vanilla essence. The next, what is happening here that you can remember? Then next NaOH and vanilla essence. Observe the smells. Then finally come to the conclusion. What the conclusion you are giving? So we observed three types of things here. Onions in the presence of acidic medium, in the presence of basic medium, clove oil in HCl and NaOH, acid and base. Next, vanilla essence in acid and also in the base. Then finally, what you are giving the result. So after completion of procedure, come to the result. So here, simply I as an indicator, I used onions, clove oil and vanilla essence. And I as acid, I used HCl and base NaOH. So onions smell in the acidic medium, it's characteristic smell. It gives you characteristic smell. So characteristic smell is what? Ice onions smell. No change. But in the basic medium, what happening? Completely it loses its characteristic smell, vanishes, changes. So completely destroyed that smell. What about with the clove oils? In the acidic medium and in the basic medium, it gives you different smells other than its characteristic smell. It gives you different smell in the acidic medium and also in the basic medium. Vanilla essence, it gives you its specified smell in the acidic medium, but no smells. It changes its smell in the basic medium. So these are the observations here. So these are observations from the activity 2. So this is about olfactory indicators. Then now we are going for another topic here, That is simply that reaction between the acid and a metal. So it is given as lab activity in 10th class academic textbook. So here, what is that lab activity? Simply that lab activity is giving idea about the reaction of acid with the metals. So to understand about this reaction, to conduct this activity, we are required a few materials. So what the purpose of conducting this activity is? The first thing for conducting this activity is to understand about reaction of acids with metals. To observe reaction of acids with metals. Next, here required materials. What the materials are required here? Here you are taking the acid. So we are collecting the acid from the lab and that we are taking as a sample into the test tube. So for that you are required a test tube or a boiling tube. Along with that you are required a delivery tube. Maybe that acid by the reaction of metals, acid reaction with the metals maybe produces a gas. I learned in the second lesson, metals, it is a chemical equations. While a reaction takes place, we have few changes. What they are? New products obtained, precipitate may be formed, gases may be evolved. We don't know what is going to be happen here, right? Whatever it may be, the products are. So for everything, we have to collect the materials, right? So here simply test tube is taken, delivery tube is taken, then I will take a glass trough. If any gas liberated, so that can be identified. Here, gases may be invisible sometimes, right? So to realize that one, we are using a glass trough and water, right? And a candle to test the nature of gas. So here is water. I am using simply soap water, that which can create bubbles, produce bubbles easily. Then next, I am taking an acid, dilute HCl. Dilute means added, dissolved in the water. That's acid and water together. Its strength is less. Next, metal. Is metal. I am using here zinc granules. Zinc granules. So these are the required materials. Also, you can include few material size here, water, matchbox to light the candle, right? Then one more, if you take a rubber cork to insert that is delivery tube, okay, single hold rubber cork. So these are the materials we are using to conduct this lab activity. Then after completing this collection of materials collected, every material is collected, then procedure. So how to test, how to observe this reaction between metal and acid or acid and the metal. In any order you can write, no problem. Then here procedure. So first of all, we have to take a stand. Retard stand. You can include into your required materials also, right? Etc. Okay. So here required materials added. Then I am taken one retard stand, laboratory stand. Next, fix the delivery tube, boiling tube or the test tube to the stand. So fix it. Taken one retard stand and fix it to test tube, fix it to the stand. The next, adding solution. Add dilute HCl with the help of a dropper. It may be 10 ml, 20 ml, just somewhat, enough quantity. Okay, this is what dilute HCl. So dilute HCl, add it to the test tube. Next, take glass trough, keep on the table beside it. Okay, glass trough is placed. The next, fill it with soap water. soap water. So what the glass top contains? Soap water in it. Okay. Next here, what we are taking the material is here simply dropping zinc granules into the HCl. So drop zinc granules into the HCl. Then after adding zinc granules, immediately you have to close that test tube, mouth of the test tube with the rubber cork, and automatically, immediately you can connect that single hole rubber cork with a delivery tube, one of the end inserted into the hole of the rubber cork and the other end inserted into the soap water. Then here simply you can observe in the glass tube, test tube, are there any bubbles formed? So here slowly you can observe that bubbles formed in the test tube. So that formation of bubbles in the HCl solution will give you an idea about liberation of gas. So here from these bubbles, what we have to understand actually, the reaction has taken place between zinc and the HCl. Bubbles formation in the test tube, giving you idea about the reaction is taking place between the HCl and the zinc. So the reaction has taken place. Okay. Here, slowly the bubbles released from these zinc granules and HCl together in the glass tube. So we are not allowing that gas to escape from the glass tube because it is closed. Its mouth is closed with a rubber cork, and that rubber cork hole is covered by the delivery tube and connected through a delivery tube into soap water. So what happens, that gas which is liberated here will be transferred through the delivery tube into the soap water. So the bubbles we can see in the soap water. The bubbles we can see in the soap water. So bubbles in the soap water give you an idea about liberation of gas by the HCl and zinc. Right? So that bubbles contains a gas. So we have to get a lighted candle near the gas bubbles so that bubbles burst, and what happens, observe. See here, the flame of the candle changed into blue color, and also it gives you pop sound. So brought a candle, lighted candle near the gas bubbles. So here simply that yellow, orange or red color flame changed into blue color, and also we will hear a sound, pop sound. So that candle catching the flame, blue color, and giving you pop sound. So immediately we have to notice one thing, that burning with blue flame and giving pop sound, giving an idea about the liberated gas is here simply hydrogen gas. So liberation of hydrogen gas is observed. Liberation of hydrogen gas is observed. So here simply what we can generalize from this activity. So here the gas liberated from the reaction is observed as hydrogen gas. So we can write the reaction as followed here. What we are taken in the test tube first, HCl. So that HCl is added by zinc. So zinc is solid. Then together they are giving you. So here we have to observe two things. One gas is observed, liberated. Then one of the liquid remains in the test tube. So two products are there. So one of the product is salt, that is zinc chloride, and other is gas liberated and decided by you by this blue color flame and pop sound is hydrogen gas. So this is the reaction we are writing from this acid and metal, right? So this is simply HCl and zinc. So what we can generalize here simply, it is an acid. It is an acid. And the metal is added. Then finally, I noticed respective salt and a gas. So observing these reactants and products, I can generalize this reaction is followed. So from this, I'm able to write a generalized equation from this. From the above reaction, what the generalized reaction we are able to write here? Acid reaction with the metal produces salt and a gas. So this is generalized reaction or equation. So whatever it may be you are taking, suppose instead of HCl, if you are taking sulfuric acid, then next suppose metal Mg is taken. Okay, so I'm changing two compounds. Then what happens? So simply it can give you MgSO4, magnesium sulfate, and it liberates the gas is hydrogen. So these are the products. So simply see here, this is an acid, this is a metal piece, and you are obtaining a liquid. This is salt, and the gas is liberated. We can identify it is as a gas, hydrogen. So simply we can write generalized equation between the acid and metal reaction producing the salt and the liberation of a gas. So this is the lab activity. Its continuation given as activity number 3. So what is that? Activity number 3 is here. Simply in the lab activity, we have observed the reaction of acid and metal. Reaction of acid and metal. Now we are observing simply in the activity 3 is the reaction of a base with the metals. Reaction of base with the metals. So what is the base here? That we are selecting a strong base NaOH and the metal piece same zinc. So what is our aim? Here to understand or to observe the reaction of bases with the metals. To observe the reaction of bases with the metals. So what are the materials required here to understand about these? Materials needed or here, first thing is test tube to collect the acid or the base. For the both, we are taking the same materials almost. Okay, here test tube is taken. Then next, delivery tube. If maybe a gas liberates. If gas liberates, we need soap solution, soap water, glass trough. Okay, then to test the gas, we need candle, matchbox, right? Matchbox, etc. Then here, along with that, we have to take here our main substances. One is base and the other is metal. So zinc and sodium hydroxide we are selecting here. Zinc solution, zinc granules and sodium hydroxide solution. Then burner. Here especially you are required Bunsen burner because you are selected here strong base. And if you observe strong base, what we have here? A metal. Sodium is a metal. So here highly reactive, moderate reactive, least reactive metals are there. Almost sodium and zinc are highly reactive. So it takes time. So to avoid that one, we are providing heat energy to increase the rate of reaction, to increase the speed of reaction, So these are the materials required. Then precautions. So what the precautions you are going to take here? Handling the glasswares carefully. Do not smell, do not taste, do not touch them even. Use the dropper to transfer the liquids. Use the dropper. So handle them, everything carefully, right? So better to conduct these type of activities in the presence of your mentor, teacher, right? So first of all, in the procedure, we will take a retort stand. We will take a retort stand and fix the glass tube, test tube. to the retort stand. Then add a base using the dropper here. So fill the glass tube with the base. So filled. So what we filled in it? It is sodium hydroxide solution. What it is? Sodium hydroxide solution. The next, I am taking a glass cup and filling that glass cup with the soap water. So soap water is taken. Okay, filled. So here, after that, just you are going to take a metal piece into the glass tube, HCl, sorry, into the base NaOH solution. So we are adding zinc granules into the NaOH solution test tube. So drop zinc granules dropped. So this is what zinc metal pieces. Then immediately close the glass tube, test tube with the single hole rubber cock, and immediately then you can connect delivery tube. Then take the Bunsen burner with a flame. Then just start heating the test tube. Then what happens? You can see that gas is liberated. So immediately connect the delivery tube into the soap solution. So on heating, slowly it starts releasing the gas in the test tube. So it can be transferred through the glass tube, delivery tube into the soap solution. So automatically you will see the bubbles in the glass cup, soap water. Then bring a lighted candle near the bubbles. So observe the flame. Slowly it changes into blue color and gives you pop sound. Again, the same observations you made here. So HCl and zinc, that reaction given the bubbles in the soap water, that bubbles tested with the burning mastic, I noticed blue color flame and pops out. In this case also, this NaOH solution and zinc also giving you the blue colored flame and pops out. So what does it mean here? Pop sound and simply blue flame, giving you an idea about the liberated gas size here, hydrogen gas. So it is liberating hydrogen gas. So from these observations, you are able to write about the reaction in the form of equation. So what we can write? NaOH is taken and zinc granules are added. So only two substances are taken here, right? Then I is a product. I observed a liquid remains in the glass tube, test tube. That is one of the product because its behavior completely different with the original substance NaOH liquid. So that's why it is taken as a new product. That is what here, sodium zincate, Na2ZnO2, sodium zincate, and giving you gas that is observed as hydrogen. So these are the products, sodium zincate and gas. So what we can generalize this equation is here, simply if a base reacting with the zinc granules produces salt and water. So this is activity number 3. Reaction of base with the metals. Reaction of base with the metals. Then we will go for next topic is here about simply it is about activity number 4. Activity number 4. What that is? Here in the activity 4, we are learning about a reaction of acid with the metal carbonate or metal hydrogen carbonate. So reaction of acid with metal carbonate or metal hydrogen carbonate will be discussed in the activity number 4. So simply your aim is, what is your aim? Observing the reaction of acids with the metal carbonate or metal hydrogen carbonate. So carbonate and the metal hydrogen carbonate means bicarbonate. Sodium carbonate, sodium bicarbonate, or magnesium carbonate, bicarbonate, calcium carbonate, calcium bicarbonate. Anything you can take it. It is not compulsory to take that substances as mentioned in your textbook. You can take any other to generalize these reactions. So what are the required materials to complete this activity? So required materials are here: test tube, delivery tube, double holed rubber cork, thistle funnel, matchbox. Then as an acid, I am taking dilute HCl and lime water. Right? So as the acid, I am taking dilute HCl. Then here one more substance is taken, that is lime water, CaOH2. Then I am needed here metal carbonate and metal hydrogen carbonate. As them, I am taking sodium carbonate and sodium bicarbonate. Here I am using Na2CO3 and NaHCO3. So these are the materials required. These are the materials required. Then next here, completing the procedure to note down the observations. So here simply in the procedure, we will take the laboratory stand and fixing a glass tube to the retort stand. So test tube is fixed to the retort stand. The next, acid reaction with the metal carbonate or metal hydrogen carbonate. So first of all, I am filling this with an acid, that is here noted to be HCl. Dilute HCl is taken. Next, here we have delivery tube, double hole rubber cork, thistle funnel. So first of all, you have to arrange them. After adding dilute HCl, you have to arrange them. So take a double hole rubber cork, then fix delivery tube to this one. Then next, fix the thistle funnel. So what is the purpose of thistle funnel here? Thistle funnel is a small glass tube and it is immersed into liquid of this test tube, HCl. Why? Here to drop solid substances into the liquid solution. Why, sir? Sometimes that reaction has taken to be very fast, right? That maybe takes place very fastly. To overcome that one, simply we are trapping the gas if releases by the reaction. If any gas liberated, that can be trapped in the glass tube by closing its mouth immediately, right? So here using thistle funnel delivery tube connected to the rubber cork to cover the glass tube mouth. So here that can be fixed to the test tube. So fixed, it is fixed. Then next thing, here dropping that sodium carbonate. First, you can take sodium carbonate. It is, I suggested, 0.5 grams, 10 grams, whatever it may be, small quantity of sodium carbonate. So add that sodium carbonate into the HCl solution through the thistle funnel. So you can drop certain amount of sodium carbonate through thistle funnel here, right? So before that, I am just using one more glass tube, right, to insert the delivery tube other end. So other end of the delivery tube is inserted into the second glass tube. So inserted, then fill that with the lime solution. So that lime solution is filled and this glass tube, delivery tube, inserted into the second test tube, which contain here lime water solution. It contains lime water solution. After that, you can drop it. What is added here? Sodium carbonate through the thistle funnel. So drop sodium carbonate into the thistle funnel, which contains HCl solution. So now observe what you are going to notice after adding this sodium carbonate into the test tube. So slowly the bubbles are going to be released. So the reaction is taking place. HCl and sodium carbonate are reacting. Then that gas slowly transferred to the second test tube, that means into the lime water through this delivery tube. So what happens? Bubbles forms into the lime water. Slowly what happens? Observe in the second test tube, in the lime water solution, that bubbles are released into this. So observe what happening here. That slowly changes into milky white color. It changes, or the lime water solution turns into milky white. So that milky white color indicating us, giving an idea about liberation of a gas. So which type of gas turns lime water into milky white? That is carbon dioxide. So here also you can bring a burning matchstick, lighted matchstick to this mouth of the lime water solution. Gas is liberating continuously. You brought a lighted matchstick, then observe what happens. So that flame put off, turn off. So if a burning matchstick turn off, put off, then you have to understand about the liberated gas ice. Liberated gas ice, carbon dioxide. So here burning matchstick put off, giving you idea about liberated gas ice, carbon dioxide. So lime water turns into milky white in color, or that matchstick put off immediately, also indicating you liberated gas is carbon dioxide gas. So simply we have got an idea about the reaction here between HCl and the sodium carbonate. So replace that sodium carbonate with sodium bicarbonate. So metal carbonate reaction with the acid completed. The next metal bicarbonate and HCl reaction. So do the same process, similar to the previous. Then observe. Then come to the reaction. What is taken place between the carbonate and acid? So that we can write as here. Sodium carbonate Na2CO3 is reacting with HCl and producing U. Simply look at these bubbles coming out. That is indicating us a gas is liberated. That is indicating us a gas is liberated. Then one of the substance remains at the bottom of the test tube of this first containing HCl and Na2CO3, and a liquid floats on it. So simply we can observe the following things in it. That is sodium chloride aqueous solution, liquid forms. Then it give you one of the substances HCl, sorry, H2O, water, and the other substance is gas liberated carbon dioxide. So three products you are going to obtain here. Na2CO3, HCl, that together giving you NaCl, H2O, and carbon dioxide. So complete the same reaction, that acid and metal hydrogen carbonate, same process. You will notice that metal hydrogen carbonate that is simply NaHCO3 and reacting with HCl, producing same products, salt, water, and liberating the gas. So testing of the gas liberated in this reaction using two things. One is lime water solution and the other is carbon dioxide gas. Okay, so from these observations, you are able to generalize that reaction between this carbonate and HCl. So before that, one more we observed here. What is that? Gas transferred into the lime water. So actually lime water colorless solution, but when you blow carbon dioxide into the lime water, its color changed into milky white. After that, it gives you undissolved material at the bottom, precipitate forms. So actually that reaction is precipitative reaction. So in that, what the reaction has taken place, we can also write that reaction. So lime water, CaOH2, supplied by the carbon dioxide, blowing the carbon dioxide into lime water, turns that into milky white color. So it can give you calcium carbonate, which can be remains as undissolved at the bottom of the liquid. So calcium carbonate, and that liquid is what? Water. So here, did you stop with that blowing of that supplying of carbon dioxide into the lime water? No, continuously we are supplying. So excess amount of carbon dioxide blowing into the lime water, then simply it gives you one more substance. Together they can mix and will give you one more substance. So here you are blowing that carbon dioxide into these products, calcium carbonate and HCl. Again you are supplying continuously carbon dioxide. So these three substances now going to react: calcium carbonate, water, and carbon dioxide. So reactants are what? Calcium carbonate, water, and carbon dioxide gas. So that together giving you calcium bicarbonate. So this is product. So from this we are able to generalize the reaction between sodium bicarbonate and acid. Sodium bicarbonate and acid producing salt, water, and carbon dioxide. See here, common products: salt, water, and a gas. So generalized equations now we are writing as following here. So metal carbonate reacting with the acid and producing salt, water, and liberating the gas is called carbon dioxide gas. So this is called generalized reaction. Also we observed metal hydrogen carbonate or metal bicarbonate reacting with the acid, liberating gas, forming the salt and water. So salt, water, and a gas liberated called carbon dioxide. So these are the products here. So these are said to be generalized equations. So this is about this class. So next I'll start the live session after a 10 minutes gap. So now the time is 7:40. I'll start exactly at 7:55 after 15 minutes break. So join in the live session. Thank you.